Let's continue practicing factoring by grouping. The last couple of examples we worked on, we didn't have to worry about the sign of the common binomial factor. Let's say we had x to the third plus 2x squared minus 4x minus 8. The last couple of examples we had all positives. Positive, 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 positive. And in this case we have different signs. Positive, positive, negative, negative. When you factor by grouping, the binomial that you get in return after factoring the first two terms will tell you what you're looking for in your next two terms. So our common factor between x to the third and 2x squared is x squared, leaving us with an x plus 2. Now that's leading me to believe that I'm looking for an x plus 2 in my next group. Otherwise, I wouldn't have a common binomial factor. It would just be a binomial. It wouldn't be common at all. So this is a positive x and a positive 2. Well, here we have a negative 4x and a negative 8. So the only way we could get positive x and positive 2 is we factor out a negative. So there is a common factor of 4 here. However, if we factor out a 4, we're going to be left with negative x minus 2. So let's factor out a negative 4. Now when we factor out a negative 4, let's just show our work over here and just show exactly what we're doing when we factor out a negative 4. We're dividing both of the terms by negative 4. Negative 4x over negative 4 is positive x. Negative 8 divided by negative 4 is positive 2. So now we have a common binomial factor because we factored out a negative. Just remember you're dividing both terms by a negative number in this case. So here's my common binomial factor. If you want to include a let statement and say let a equal x plus 2, then it might be a little easier to factor. But if you wanted to go right to the common binomial x squared minus 4 times x plus 2, that's fine. The let statement simply helps you factor this. So now we have x squared times some a minus 4 times a, where a is represented by x plus 2. So we have a GCF of a, and we said a was x plus 2. So let's plug it back in. Now, yesterday we were done factoring because we would have had x squared plus 4. Today we have x squared minus 4, which can continue to be factored. This is the difference of two squares, so we're not done yet. Although we yielded an equivalent expression, this is not completely factored. So let's bring down this x plus 2 because this is already completely factored. But this is the difference of two squares, so I'll set up two sets of parentheses. Take the square root of the first term, take the square root of the next term, make one a plus, make one a minus. Now this is factored completely. Here's another example. Let's say we had 2x to the third minus x squared minus 2x plus 1. Now let's just note the signs. Positive, negative, negative, positive. So something's wrong here. Positive, negative, negative, positive. So that means our binomial is going to be negative, and this binomial will be positive. So we'll have to factor out a negative at the next two terms. Let's factor these two normally. The common factor here is x squared, leaving us with 2x minus 1. Well, this is positive 2x minus 1. This is negative 2x plus 1. So really all we want to do here is change the signs. So let's factor out a negative 1. Let's go to the side here and show that factoring out a negative 1 means we're dividing both terms by -1. This is not necessary. This is just to show you what's going on the inside of the parentheses here. Negative 2x divided by -1 is positive 2x. Positive 1 divided by -1 is -1. So here's my common binomial factor. My common binomial factor is 2x minus 1. After I divide both of these terms by 2x minus 1, I'm left with x squared minus 1. Okay? This is the difference of two squares. We can continue factoring this. This is factored completely, so I'm going to bring it right down. But the difference of two squares will yield two more sets of parentheses. Take the square root of the first term, take the square root of the next term, make one a plus, make one a minus. And this is factored completely. So just to summarize, you have to factor out a negative if after you factor your first term, you have a different direction of signs than your next two terms. After we factored out this term, we had a 2x minus 1, a positive negative. The second term began with a negative positive. So there isn't a pattern here with my signs. If these signs were positive, negative, positive, negative, then we would not have to factor out a negative. If these signs here were positive, 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 I would not have to factor out a negative. If these signs here are negative, positive, positive, negative, then I would have to factor out a negative. There has to be a pattern here